Yeah. Though we know who we are, yet we know not what we may be. So maybe I'm the one, or maybe I'm crazy. I'm from.
Welcome back to your No Malarkey Guide to Programming. So in our last video, we got this up right here. We just figured out that the average height was 79. In case you already closed this window, we're just gonna close it ourselves and go back into it just to show you that it ain't no thing. It's real easy to get back into it. And by the way, I hope you guys are having a wonderful day. It is a great day to be learning programming. Hello to all the high school students I got watching this video. Hello to all the grown people who are trying to change careers I got watching this video. Hello to my mother who is watching this video. Hello to my nephew who is 8 years old, who soon will be 9. I think he already turned 9. I apologize. Who is watching this video. So this really should be accessible to all fields, and we're going to get started. So just open up your terminal, and we're going to log in CD into our desktop as we are used to doing, and we're going to CD into linear regression. And once we're in linear regression, we're going to do source linear regression VNV bin activate. And once we are activated in our virtual environment, we're going to write Python, and then we should have. Actually, I'm going to quit Python and then do ls to let you guys know that we have this file here. And I'm going to write Python again. And then we're gonna write this a lot. Import pandas as PD, import matplotlib.pyplot. And we imported this last time, but we didn't use this as PLT, but we're gonna use it now. And import data, import numpy as NP. And we also didn't use numpy now, but we will use it. Maybe we'll use it this video. Maybe we won't. Maybe it won't be until next video. So we have imported all this, and to get back our data, we can do data equals. We need to open that. Where is it? This right here. We need to open this. So data equals PD. We're going to use pandas open read method right here, or read CSV method, and we're going to pass it this MBA underscore HTWT CSV. And remember last time that it required this encoding equals. So I'm just going to copy that and then paste it using Control-Shift-V, comma, and give it an encoding. And it is now read. So here is our data, and we can do heights equals, I'm just going to call it H. No, I'm going to call it heights. Heights equals data heights. That's because it isn't called heights, it's called heights with a capital H. And if I did it with a lowercase h, it would give us an error. It would say key error height. So we need a capital H because it is case sensitive, and right here it's a capital H. So we can do height, and we have that column, heights. Great. And as we remember before, we did heights.mean, and we were able to get the average height. And why don't we visualize this first off? So we're going to use PLT or plt.scatter, and we're going to give it this x and this y, and we can visualize it. So x and y. Oh, I'm sorry, that was a terrible thing. So we're just going to give it this heights. Okay, we're just going to give it the heights, and we want to visualize what the heights look like. So we're just going to give it the heights. Let's do plot instead. And then plt.show. And this will show you, let's kill this. Let's do it again. And when we do plot, we're going to do comma and pass it this dot argument right here, surrounded in quotation marks. And we're going to press enter and then run show again. So this will show you a nifty little graph. Why don't we make this graph better? Let's give it some labels. So the y on the graph, so let's do plot again, and then let's give it some label. Y label is MBA is heights in inches. And then the x label is just number of players. And I'll show you guys what this means. So let's do plt.show again. So here it is. We have our labels, heights in inches, and this is like player 1, player 2, player 3, player 4, player 5, player 6. So remember, player 1 is our favorite, little fire starter. Nate Robinson. I will never forget that playoff game. I think it was against the Heat where everyone was injured and he just went off. But anyways, it's neither here or there. So this is our first record, and this is our second record. So 1, 2, 3, 4, and we have 504 players. We can see, just to make sure, we have 504 players, with the tallest player being Hashim Thabit. And that's just what this graph shows right now. So why don't we get the average? What is the average? Is there a way we can like get a horizontal line? So let's say horizontal line, and we want to plot a horizontal line on Matplotlib. So we can just search this and figure out right away the ways to plot horizontal line. Is the Stack Overflow. It says plt.axh line. So why don't we try that? I'm going to close this right here, and I want to plot a line that represents our average. So we can do plt.axhline, and then the y-intercept is just going to be, let's just make it our average. So our average is heights.mean, our average heights, and then I'm going to close this, and then I'm going to run plt.x label, y label, and plots, x label, y label, and show. And here it is. Here is our graph again. Except now this represents the average height. So the average height is about, let's see here, about 79, 78. And we can just close this to see. Well, we already know that the average height is 79 inches, about 6 feet 5 inches. We saw right here 79 inches. So we can guess that we have a bit of error. If we wanted to guess how tall this NBA player, he can be anywhere along the spectrum. So this isn't a very good guess. We can't just go with the average. We need to know like how good or bad our guess is. So what if our NBA player actually was Nate Robinson? Dang, we would have this massive error rate between our assumption, the average 6 foot 5 inches or 79 inches, versus what Nate Robinson is, 5 foot 9 inches, which is like 66 inches or something like that. So we want to predict, one, how much error is in our estimate, and two, once we understand how much error is in our estimate, we want to say, can we make this a little bit better? Is there another method? Is there any more information we could get about this mystery player that's going to make our estimate a bit more accurate? So that's what we're going to do in the next video. We're going to actually finally get started on linear regression. We're going to take this other piece of information that we have. This information is their weights. So we have their weight. We can say, what if we also, for some strange reason, knew this mystery player's weight? That would be a lot more helpful in trying to guess how tall he is. So we can ask a different question. Given the mystery player weighs this weight, how tall could we expect them to be? And then we can also figure out, we can have a guess, right? And then we could also figure out like how wrong our estimate is. What is the likelihood that this guess has a lot of errors? And that's what we're going to do in the next video. It's going to be very exciting. We're going to finally use a linear regression library. I'll see you guys at the next video. Thank you for your patience as always. Peace.
Financial freedom, my only hope.